We have three discussions this afternoon. The first one is Hannes Tschofenig and Rob van Eijk, and I'll just moderate that one. Then Frank Dawson and Alton O'Carroll will have a discussion on the privacy engineering approach, moderated by Marit. And the third discussion is between George and Stefan on the real-life situation of researchers and citizens or data protection. And we shouldn't take more than 40-45 minutes for each of these conversations, so that we have enough time left for the wrap-up, and that should be the real actionable items. And so I have already taken far too much time, but I think maybe used it wisely. And I would then ask Hannes to throw us into the first discussion.
I will again stay here, but Rob sits nearby. So I wanted to start with, since this section is about the privacy considerations, and I'm trying to, or we both are trying to figure out like what specifically can be done beyond just talking about the gaps. I would like to start with sort of a recap on what some of the challenges that we saw in trying to provide some guidance for privacy design in internet protocols, and maybe there are some ways forward from that. Working on this document that I presented in the morning, which gives this sort of guidance to protocol designers, and maybe some of you have actually read it or looked at it. There were a few really significant challenges that we had to overcome, because we initially thought that it would be a straightforward exercise. We just take existing privacy principles published by the OECD privacy principles or so, or use the privacy impact assessments, and we would be done with it. But it turned out that the scope of the work of the organization, or any organization, is often rather limited, more limited than one would think. But on the other hand, it tries to develop very generic technology. So concepts like purpose limitation and data minimization turn out to be quite complicated at the level of the protocol design, because you're not designing a pinpoint solution, but instead a generic building block, if you will. And so any sort of like specific guidance on what not to do or what to do was a challenge. Of course, it's quite tempting to give recommendations to people who you are not directly interacting with, because they obviously don't speak against you. So we could only really talk to developers, standardization people, not implementers, not deployment communities, and so on. Which of course is the main audience that we typically deal with, but many of the privacy challenges show up later in the process. And once we actually got things established, just having a document by itself doesn't help. We wanted to, as part of the process that exists in the development of standards, we wanted to have reviews. People, other experienced people, ideally privacy experts, reviewing existing work and then providing feedback to those who write the specifications, who maybe are less aware of privacy aspects. And it turned out that that's actually quite difficult, because first of all, you don't have too many privacy experts who volunteer to spend their time on reviewing other people's work, even if they understand what the work is. But often the privacy experts don't understand these specifications. They find it very confusing. And so having them to give feedback or review, do a detailed review was complicated. On top of that, it's more time than you would think, because it's not just a review, you drop it over the wall and then you expect these people to do what you said, but instead they ask questions back, they challenge you, they want a specific recommendation, And that turns into like a fair amount of work. And these reviews are not only a challenge in the IDF, but also turned out to be challenging in the W3C as well, as I mentioned this focus on reviews in the W3C. So having some actionable reviews, so like what should the specification writer instead do, is non-trivial, and finding people for that is difficult. Also difficult is to find people to do a privacy analysis beyond the single specification of an entire architecture, because that assumes that you understand a much wider set of specifications, potentially very cutting-edge technology. And try to find these people. So the people who are really familiar with the technology, they are often involved in the design. They don't have the time to do that. They are mostly in a write-only mode, and do not sort of write these sort of meta documents. So we try to raise the general level of awareness with education sessions. We had actually one a year ago in Berlin. There was an IDF meeting in Berlin. I led that privacy tutorial, and it was quite well received. We had lots of participants, so lots of interest. But it was, you could see the conflicts very quickly, because there are obviously certain business models that run against it. So as an example of a current discussion is on HTTP and the use of proxies. And so clearly there are companies who sell HTTP proxies. They do all sorts of filtering, they do deep backend inspection, they do transcoding of video streams, they do all sorts of caching and so on. And as you've seen the previous picture, if you turn on encryption, you can't do that stuff anymore, quite clearly. And so these companies, firewall vendors, telecom operators, are then upset. They think that their business model is being destroyed by some geeks. How is that possible? And so they ask, like, okay, so now how should we do spam filtering? And those are sort of interesting discussions, as you can imagine, and it's not so easy to find the way through them because you are cutting out certain business ideas. And of course, as I mentioned in the introduction in this morning, we don't really provide any guidance for implementers or the guys who deploy with those recommendations, which of course the hope is that someone else would come up with those, but that doesn't magically happen for some reason. And so we're still looking for those, or at least, as George put it, to identify some high priority items, and maybe that can be done there. In limited sectors, like the work that Stephen had been mentioning, there with communication security, specifically with the increasing interest on transport layer security, there were people, or there still are people around who write much better guidance on the use of transport layer security, for example, for website administrators, as sort of call it a copy and paste tutorial. So you want to configure Apache with transport layer security and OpenSSL. Here are basically the steps, copy text, and that's it. And that's something that is obviously needed to sort of lower the barrier for someone who is a system administrator or developer. That really helps. But of course, it would be needed beyond that limited set of technologies. So I think that's enough for an intro and a little bit background on the work that we've been doing. Rob.
Well, thank you, Hannes. Well, if I summarize your approach at the moment, is you're building it up from a protocol level. So I turn the problem upside down and I'll approach it from a society level, and then we see whether we can fit somewhere in the middle, and I've got some ideas about that. First, and I don't think every lawyer would agree with me, but I take the perspective that society is changed by technology and not by law. Because in the end it matters how the people are going to use the technology, and that's not necessarily the same use as the designers or the companies who created the technology envisioned. For example, take WhatsApp. WhatsApp was designed as a free replacement for SMS, and what's actually happening now is that WhatsApp is being used by people as a replacement for email altogether. And that's quite beyond what has been envisioned from the design table when they started creating the WhatsApp. The other thing is that it's also about how the data is used, and if you look at the metadata, it's like an important element, that the data may express more than the data flow itself, and in the analogy of WhatsApp is that the data is an expression of your active life. And that active life, the active people you communicate with, is much more detailed and fine-grained within the WhatsApp metadata than in comparison to the Facebook network of friends. So the reason for that being is that these services have been created, on the one hand, to be beneficial for the users, so people start using it. But on the other hand, and I think that is like the dominant driver, is it's because the user is the product. So these products are being designed, in my view, because there's a need to learn and to know a lot about the users that are interacting with your platform. Well, that said, looking at how the communications went today, and seeing that there's a gap between the influence an engineer can have in terms of using protocols and standards and frameworks versus the legal obligations in terms of how do I reach a compliant system. There's much to be said, and I started my 3 slides this morning with that the right of privacy stems from the human right, and that's like, it's the charter, it's all things that have been worked on for many years, and these evolved into principles, and it's very interesting to see, and I'll just name 6 principles that are fundamental from a privacy perspective. The first is the legitimacy of the data processing, it's data minimization. And all those words don't really sound well when you express those to an engineer. They have no idea what you're talking about. And if I'm now looking at, if engineers would have to strengthen these principles, which then would be principles that are maybe easy to solve, or maybe we can contribute to, and other ones that are very difficult? Well, as the What Do They Know series have shown, is that on the principle of transparency, a lot has been gained from an engineering point of view. Even Stefan was showing with the cookie viz and other initiatives, it is possible to visualize data flows and to show that a lot of tracking, actually monitoring is being done. And I'm now referring to the dominant model on the internet, which is the advertising model. And people were shocked by that. Recently we had this research paper from the University of Leuven. Everybody knew that due to the e-privacy legislation, cookies are just a hassle for a lot of companies because the consent is difficult to gain, in their view. So fingerprinting could be another means to recognize a user over time. Well, fingerprinting is just one example. You can trace then and say, okay, we have a new phenomena, but how far-reaching is that phenomena, and is that a relatively new phenomena, or has that been practiced over time already? So transparency is a principle we can contribute to very effectively. But when I then go through that list and think about, well, how could engineers contribute to, for instance, purpose limitation or data minimization? That's from a completely different nature. For purpose limitation, it's very unlikely that the engineer is going to overrule the product owner or the one who is basically making sure that the engine keeps running within a company. So it's very good to express that we should not use the data that has been collected for legitimate business purposes, for instance in security logs for different purposes. A lot of times you hear, well, we have the data already, so why we do not use it for something else? But it's very difficult from an engineering point of view to make a difference there. And the same is with data minimization. Even if you say, and this is a phrase well expressed by the privacy by design point of view, select before you collect. Well, even if you end up with only one identifier and you collect these data points over time, that's enough to create a very detailed picture and to have an impact on the person's life. So it's not like the ultimate thing. You can basically cut out all the unnecessary information and still what's left may be very damaging in the end at all. So Hannes and I were brainstorming a little bit in the break, and we were thinking maybe we shouldn't try to solve all the problems, but maybe we can identify some areas where engineers can actually contribute. And the way I look at it, there's like 3 things I want to add to that discussion, and that's the first thing. We should maybe look at areas where there are enough building blocks already. So not having to develop new building blocks, but being able to tap into a wide collection of existing building blocks. The second thing, it should be something where we will have a big impact on the way the networks function, how the things work. And the third thing, and that's a lot of times overlooked, it needs to be enforceable. And that means it needs to be something that DPAs understand and also agree that it's very effective and that it's needed. And because a lot of DPAs have been dominated by legal scholars for a long time, we do agree that, for instance, on the topic of security, there's a lot to be gained. If you have like a web form, I can explain to every colleague in my office that if a web form you have to fill in these free-form fields, and there's like well, information in there that might be sensitive. There may be like medical things you need to fill in or telephone numbers. They know that you need a little bit more security than just the plain HTTP, because they know that the best practice in the industry is to raise the level of security. So coming from that, there may be 2 fields that we may draw upon, and the first thing is to look at which building blocks could be most effective, and the second thing is the configurations in terms of security that could also be taken into account. And the example I have with that is, for instance, email. If I look around at the internet service providers in the Netherlands, it's not that for instance, the POP protocol or the IMAP protocol to pull your mail is by SSL or TLS by default. All the internet providers still provide access to your email over clear username password, and that's something that should be made impossible. It should be clear, and therefore I think it's enforceable that if the building blocks are there and it's clear that if you have multiple purpose tools and you configure them well, you can make an impact, which we just saw on the slide, which Achim showed, that end-to-end encryption and maybe encryption in general, and Hannes knows a lot more about that in terms of forward secrecy, etc. That might be a good starting point for this discussion. So,
yeah, I was wondering, sort of leading over to, and maybe I'm handing over to Achim, to involve some of you. I'm sure your blood sugar level is low, you're tired, but we were sort of, since we only have 1 day at this workshop, in trying to come up with some sort of actionable items, we were wondering what those would be, and as Rob said, like focusing on one item like the communication security as an example would be potentially interesting to see what could really be done, who would really be interested to contribute to some specific items, so specific work in terms of, like, I don't know, offering recommendations, offering reviews, picking certain implementations, or finding researchers who could actually contribute something if most people are probably not in their capacity, sort of have resources to really offer help themselves.
Thank you.
Just a question on that, Hannes. I mean, how much of a problem are you talking about there in terms of technology? You know, if the choice appears to be so simple, encrypt username and password for login when using mail services. Are we talking about a legal question here?
So, I mean, I think there's no technical problem with, you know, in a world where you required IMAP to be always accessed over TLS, there's really no technical problem with that. All of the technology does it. There is a long tail problem. You know, so probably, you know, 90-some% of mailboxes are already accessed that way, because there's so many large mail providers. But then there's a long tail, and I don't know how big that is. Of, let's say, people who are still using their ISP's mail provision as opposed to Gmail or Yahoo or whatever. But there's no technical issue that wouldn't be easily solvable by anybody who wanted to update their IMAP server to only accept SSL connections that I know of.
Well, email was just an example. Of course, it doesn't need to be email as such. We mentioned Internet of Things, communication security. There's the exception rather than the rule. And getting the keys there and getting the stuff updated is a completely separate business. So there's a couple of related questions once you go a little bit deeper into that, and the same is also true for, like if you look at other communication technologies besides email, like instant messaging tools and so on.
To the practical issues, and one question I take what Hannes and Stephen and the others say, can we say that it would be state of the art today already to use StarTLS for any mail portal?
So StarTLS is used in various ways in mail. There's between mail servers, and the latest figures are showing that 90-some% of email traffic is already encrypted between mail servers that way. But that's 90% of messages. So when one of the people measuring is Facebook for when they send out notifications. So they're measuring that 90% of the mails they send out. But there's still a huge long tail of maybe a few 100,000 mail servers in the world, and we don't know what the situation with those is because they do so little traffic. For accessing your mail server over IMAP, I think you can definitely say that the only thing you would ever need to do to get that to work is just to upgrade by a cert, maybe.
What I had in my mind when asking this question was, I mean, I'm very intrigued by Rob's three criteria to select, which is where the technology is already there, where we will have considerable impact, or where the measures will have considerable impact, and things which are enforceable, which means basically also in the first place verifiable. So it must be possible to see whether it's there or not, rather than I don't want to get too much back to security of communications, because that's also a discussion of its own, which has a dedicated community with spending a lot of work on it. But so for the continuation of this first conversation, I think a question would be, where are the areas where we can say there is a state-of-the-art, which is better than what may be the widespread thing, and so where also, rather than inventing new tools, we could just say these methods, tools, and capabilities are what we couldn't expect today. And that would be a guideline then for data controllers, of course, but also for data protection authorities, which they could use in their enforcement work by saying, well, there is a generally accepted state-of-the-art, and you're just below that, so that's not okay. Before I give it back to the panelists, or to Hannes again, who's, I'll just go around the room and the chat channel, whether there are any requests for the floor on that. So, yes, I see that. So, Carlo, and then we continue.
I wanted to challenge the idea of generally accepted, because it is pretty hard to make anything get generally accepted, and by the time it's generally accepted, it's really, really late. And what we need is to focus on developments that could be made and are just not being looked at because they're not backwards compatible or because they are not immediately solving the email problem. Well, there is no solution for email. Email will never be safe. And so is for a lot of the current internet technologies. They are so fundamentally broken. SMTP, HTTP, DNS, X509, XMPP, you can all give up on those in the long run. You might be doing minor band-aids there, but there are such fundamental issues with all of them. And we are so close at having other kind of approach by having end-to-end encrypted channels available directly as an API on your own device. And you can have communications with other nodes, which may be commercial, might be companies or might be human beings. And you can develop applications on those, and you can barely do anything wrong because all the application needs to do is talk to another person. And everything else, the encryption, the metadata protection, and the privacy is done deep, low, in the design. And I'm not just talking about GNU-net, I'm talking about Tor, about I2P, about CJDNS. There's a whole series of tools which is heading in this direction, and they are done by hackers because nobody else is really understanding it. Okay, we also have 10 years of research at universities going on in that field, which is very, very important and relevant, and which is completely out of the visual from the ITF, for example. The ITF doesn't know that this research has been going on, and is missing out on the potential which is connected to that, like replacing the current internet routing backbone with something that actually works. I'm getting a bit nervous because there are 99.9% of people are focusing on band-aiding the current situation, and so little interest is being spent in looking at how could we do an end-to-end metadata protected mail system. Well, it means give up on SMTP. You might be able to keep some of IMAP, but really, why would you want it if your own device should be receiving the mails and there shouldn't be a server anywhere anyway? And similarly, several other technologies need a completely different way to look at. And we have the potential of exchanging cryptographic identities of the nodes that we want to talk to. And at that point, we don't need any authority to guarantee a certificate, and we don't need any authority to resolve a domain name. So, yeah.
Thank you, Carlo. I think you made your point in an extremely clear and understandable way. But I feel that I should give the people band-aiding the current internet the opportunity to react on that one.
Yeah. So, I mean, I think clean slate approaches are great, but they are that. I mean, there are, whatever number of billion people connected to the current internet. Replacing the default free zone with something else is like a massive undertaking. I mean, if you succeed, I'd be delighted. And I think, for example, you do have some good points about email. It's very hard to see how to properly get end-to-end security for current email. There are probably ways that are less clean slate than others. They may be very messy, but I think the assertion that it's feasible to just ignore the current internet and go to clean slate seems to me to be not really justified, and the idea that we should not try and improve the current internet seems even more broken. So I think there's a bunch of work to do. We should do that, and at the same time, if some clean slate approach gets traction, super, we'll deal with it then.
Thank you, and Jan.
Well, we can discuss the justification. With my statement, I wanted to start with practical approaches. One idea that I've been pitching to people for a while is do a more bottom-up approach and just starting with the building blocks we have and develop some set of tutorials, maybe from this group and some others, with just basic ideas of what we consider paths or privacy by design approaches, and just put them together. So we have a set of limited 5 to 15 minutes tutorials on various aspects, and we can start sorting them out and giving them a structure. And I'd be volunteering to be an anchor for such a project for the next year. I'd be very interested in doing that. Another practical approach would be email, and I knew that was raised objection from my left-hand side, and I very much agree to that objections. However, we now have a chance and see a lot of organizations, given the Snowden revelations, that want to implement end-to-end encryption over email, and they're not ready to get rid of email yet, unfortunately. So another thing in the realm of what Hannes just mentioned is maybe we should look into best practices in these areas. Of course, there's the OpenPGP standard already there, but that has certainly a number of limitations. I would one side would be to revise that RFC, if it ever gotten status of an RFC, but I think it did. And the other would be the surrounding best practices, which may be more in the organizational than on the protocol side. So how do you actually deal with keys on a very, very practical level for an individual? Do you want to print it out? Actually, yes, you want that medium. You want that hardcover in some cases because it's a lot easier to deal with on a practical level. Other areas would be how do you avoid some of the metadata leaking? You probably can't, but you could probably avoid at least some of your social network data leaking if you are using smart approaches. But that will be subject for discussion for new documents, potentially in ITF or other forum. But now I'm coming back to what Carla just said, and I fundamentally agree, and I'm biting, being the troll here, and it's been having had a hard time to sit on my chair here. We're talking about the problem or the problems of privacy on the internet here, and I sense its problems, but there is a fundamental problem that's been the elephant in the room for 25 to 30 years, and that's control and accountability, and we're not solving it currently. So. I think if we want answers, there's three obvious things that we need to envision, and that's data minimization and separation to start with, and that's probably at its core decentralization. And as long as crypto isn't reliable, and I'd argue that it's in a lot of cases not, the whole communication would stop there. But going on from there, we're probably looking into underlying protocols and towards a good start. And if we're taking clean slates, I'd opt for doing the traditional 2 version step and going for IP version 8 right now, and looking into that area. What would be a Tor implementation on an IP kind of ISO OC stack? Because if we don't start with maximum privacy to begin with and then put the identification on top, there is no chance for so-called cultural differences in privacy in the world to establish those, because it's always going to be determined by those policy implications of the underlying protocol stack. And if we don't take that out, that's not possible. Despite the fact that I don't think there is so many cultural differences as people from Yale argue. I think it's a completely stupid article, to be frank. But that's a different topic. And finally, even if we get there to establish such a basic level, then we would get into the sphere where we could actually do the difficult point, and I like that very much from Stephen. There is no problem to solve then. Then that's a policy discourse. We really have to decide, do we want as a society or as a European society this type of processing in our market, or don't we want it? But currently there is no regulatory mechanisms to do that, because the underlying concept is flawed, and we can't really build on top of that. So there are more fundamental problems, and in that I want to very much support Carlo. But coming back to my initial thoughts, I think we still have to take practical steps. Thank you.
Thank you, Jan. And George, please.
Yes, thank you. I also wanted to express my skepticism about the roadblocks to deploying more widely quite mature technologies like TLS. I was earlier this year in the Sprint workshop, and I heard the people who sell those boxes that apparently absolutely need traffic to be in clear for them to operate. And my main worry there is to what extent the IETF process now is captured by people who, you know, frankly speaking, I'm not really sure how large their interest is in this, but clearly they have some personal interest in that. And to some extent, you know, they're ready to fight their corner at the expense of the public good at this point. And generally speaking, I have this feeling every time I hear these arguments that, you know, we are acting as if the situation we're in today is okay, it's tolerable, and, you know, we have to be very careful not to step on anyone's toes, because fundamentally nothing really is broken. And there I really, you know, I would also back up Carlo in saying, yes, the internet currently is broken for most of us. So, however, I don't actually think that engineers have to bear the, you know, the mass of blame here, and therefore I would like to also turn my argument to our colleagues from data protection authorities, particularly our technical colleagues from data protection authorities, and ask them the following. As I was browsing earlier and as I was using my phone earlier, a lot of my traffic was actually transiting in clear over a public network, a lot of it. Why do you consider that these applications a priori are compliant? Why are you not just making a list of any application that actually, or web application that doesn't use HTTPS, and not immediately and automatically finding them? I do not understand. At the same time as we have the largest services on the internet, namely Facebook and Google, who really have billions of clients managing to scale up encryption, why do you consider that this technology should not be enabled by default, and therefore flexing your regulatory muscle in order to make it so? And this is actually a genuine question, because I do not understand the constraints under which you're operating.
So, I'm not going to answer the question right now, focusing on, but Rob is willing to take that, that's great. I have two last remarks for this round before I hand over to Marit to enter into the next discussion, but I think we should stay on the topic, on the issue, on what to do. But we will have another perspective, and that of the inside developer perspective in the next round, which I think is also important. But I would, Stephen and Rob and Hannes, close this round, and then please remember, be short. Thank you.
So very quickly, so on the topic of mail, I think we're sort of in agreement. There's a bunch of people trying to provide new ways of doing end-to-end security for mail or mail-like things. We started an IETF mailing list to discuss whether there's components the IETF could provide that would help them do their stuff. And then when whatever they've done is mature enough to scale, maybe you standardize it later. But things like, you know, let's say key access, key recovery, or something, public key access from some kind of addressing. So, I mean, we're quite willing to work with people on it. On the question of why not find people, technically I think the likes of Google and Facebook have a different kind of deployment infrastructure than a kind of a middle-sized site would have, and it's harder for some smaller sites to actually move to TLS everywhere than for some people like Google and Facebook who have much more homegrown server infrastructure. So it's not always easy for a small site to transit to HTTPS. As it would be for Google, where the endpoint really is where the application is, as opposed to in some load balancer. So there are some technical reasons why that might be tricky. And then the last thing was, if one of the practical things you do want to do is to look at something in the space of current email and not kind of end-to-end security, but let's say with IMAP, there's an organization called MOG, the Messaging Anti-Abuse Working Group. And actually it could be quite fun if you guys got talking to MOG, because MOG members are quite often people who send out bulk email. However, MOG also has a bunch of ISPs as members, and they do have a working group now on looking at what to do about pervasive monitoring. And the people from Facebook who did the turning on TLS, start TLS for their mail infrastructure are people who go there. So that might be, if you decided to take a concrete step in that space, being in touch with MOG would be useful, and I could help there because I'm one of their, some kind of free expert or something that I don't have to pay their fees, but I get to go to some meetings. So that could be an interesting collision between the data protection agencies and the people who send what I would consider spam.
Okay, let me respond. First, do not be mistaken. We are enforcing against the lack of proper encryption. And to give you 3 examples, I can only speak for the Dutch market here. We did enforce your pharmacy or to get an appointment for the doctor through an online system. Those really have been addressed in a sectoral way, and the whole sector is actually making changes to make that the default, at least in the Netherlands. And the third one is, if you look at WhatsApp, we addressed the security flaws in the protocol, and WhatsApp has upgraded to a very solid, based on SSL, a library to make sure that the messages are actually being transported in a secure way. So that's the first thing. The second thing is, you have to understand that not all DPAs have finding capacity. In the Netherlands, at least, we can say that if we would have finding capacities now, we would use those abilities for sure. So it's good to know that in the legislative process, finding capacities are being taken into account. And if everything goes well through Parliament, we may well have finding capacities in the near future.
Okay, thank you. Oh, Hannes, yes, please.
Yeah, I thought Carlos' comment was interesting because it shows the tension a little bit between sort of a more evolutionary approach that takes into account all sorts of different deployment issues and sort of the more clean slate approach and all the variations in between. And in the email case, we can clearly see all the different options. And there are about 30 or so projects ongoing that have addressed it, different flavors of it. But in context of this specific group, it's a little hard to say on what one could do, because ultimately you can't really work on the technology as part of this group. There are probably some other researchers who could, but that can't be the effort of a group like this. It could probably facilitate and arrange, but it can't do the actual technical work. It can't also, or it will not have deployment impact in that sense of like which technology to push. That's often a market decision and is in the hands of companies. Some of them start small and become powerful, and some others never reach that state. And so that's difficult either. If it would be so easy to push for some new technology, then why wouldn't we do that all the time? Or everyone would do that. Everyone who works on a project wants to have their project be of the size of Google ultimately. So what would specifically the work would be, and I think Rob's sort of guidelines are quite useful in that extent, but I hope as walking out of this session, it would be great and useful for us to, if you think about your own work that you are doing and how you or your colleagues actually could contribute in what form specific activities, very much like Jan did with what seemed to be a small effort like with tutorials, but it actually, if you think of it, break it down to the actual items, it's still a fair amount of work that needs to be done then. So if there are some further recommendations, don't hesitate to drop me or Achim or Rob a mail, and we would like to collect those ideas and try to cluster them if there are a couple of people who would like to work on the same efforts, put them somewhere on a wiki or like coordinate a little bit. Because it's one thing to talk about ideas and the other thing to actually really do something, to work together on some projects.